All right, we are in lesson 2 in chapter 8, so 8.2, and you are going to be learning about function rules and figuring out function rules from numbers. So there is a lot going on in this lesson. So let's start with the vocabulary setup. This says a sequence is a list of numbers in a specific order. Each number in the list is called a term of the sequence. Arithmetic sequences can be found by adding the same number to the previous term. In a geometric sequence, each term is found by multiplying the previous term by the same number. So let's get those definitions down to compare them. First, arithmetic sequence. So it is a sequence where you add by the same number each time. Okay, so get that written down. Sequence where you add by the same number in each time. So for example, you can start anywhere. Maybe I'll start with 10, and I'm going to add 2 each time. So plus 2 is 12, plus 2 is 14, plus 2 is 16, etc. That is an arithmetic sequence because I added 2 each time. Now for geometric sequence. So it's a sequence where you multiply by the same number each time. So let me give you an example. Let's start with 1. And if we multiply by 2 each time, so 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, etc. Geometric sequences get bigger much faster because you're multiplying, and that makes numbers get bigger quicker. So know the difference between those two sequences. Now, on the next page, we are going to go through some examples where you find the next term in a sequence of numbers. So in example 1, it says describe the relationship between the terms in an arithmetic sequence 7, 14, 21, 28. Then write the next 3 terms. Notice this asks you to do 2 things. Describe the relationship, and then write the next 3 terms. So when you're looking here, it's an arithmetic sequence, they told us, so we know it's going to be adding the same thing each time. And if you look going from one number to the next, 7, 14, 21, 28, you're adding 7 each time. Now, the describe part, where you have to write a sentence, I'll highlight that here, you might want to underline it. Each term is found by adding 7 to the previous term. Okay? Now, that's the first part you need to do. The second part is find the next 3 terms. Now, if you are adding 7 each time, you would just have to add 7 to 28, and 28 plus 7 is 35, plus 7 is 42, and plus 7 is 49. Oops, that should be a 9. So you have to describe and then find the next 3 terms. Now in 2, again, it says describe the relationship and then write the next 3 terms. Now this is a geometric sequence. So if you look down here, they start with 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So where you describe is right here. Each term is found by multiplying the previous term by 2. And then finding the next 3 terms, you start with 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. And it's okay if you use a calculator for these, no big deal. Alright, so now in A, B, C, and D, we have to do these for you to... We're going to do these. I'm going to do problem A with you, and then I'm going to have you do B, C, and D. So in A, they don't give you much room. The first thing we have to do is describe the sequence, and then we're going to find the next 3 terms. So when you're looking here from 0 to 15 to 30 to 45, I notice 0 plus 15 is 15, 15 plus 15 is 30, and 30 plus 15 is 45. So I can already figure out part A. And you could write it over here if you want. I'm just going to write it underneath so I'm not scrolling back and forth. So part A, or problem A, you would say each term adds 15 to the previous term. That should be an E. Don't you love my handwriting? Okay, so that's part A. You have to describe it. Now, the next part is you have to find the next three terms. So if I'm adding 15 to it, if I do 45 plus 15, I would get 60. 60 plus 15 is 75, and 75 plus 15 is 90. All right, so that's problem A. Now I want you to do, let's see, I'm going to have you try C next. So do C, pause it, and when you're done, restart and see if you're right. Go. Okay, let's see how you did in C. So in C, I'm looking at my numbers here. So I have 1, 3, 9, 27. I might check for adding first. So 1 plus 2 is 3, 3 plus 2 is 5, not 9. So it's not an addition sequence. So let me try multiplication. 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27. All right, so it's a geometric sequence. I'm multiplying by 3. So the first thing you should have done is describe it. So I would say each term is multiplied by 3. Okay, so see, you don't have to have the same exact words that I had from A. So each term is multiplied by 3. Now for the next three numbers, this is where you might want to use a calculator. All right, so if it's times 3, I'm at 27. 27 times 3 is 81. 81 times 3 is 243. And 243 times 3 is 729. Remember, I hope you used a calculator for that one. All right, so I want you to do, let's see here. I want you to do problem B next. So describe the sequence and then find the next three numbers. Pause, do B, restart when you're ready. Go. All right, let's see how you did. So when I'm looking at this one here, it's going 4.5 or 4.5, 4, 3.5, 3. I notice each number is going down by half. So I'm going to write that out first. So this is problem B. You subtract half, I'm going to write that as a decimal, from each term. Okay, so that's what you're doing. You're taking half away from each term. Now, for the next three numbers, if we started with 3, take away half, you're at 2.5. Minus half is 2, and minus half is 1.5. They're the next three terms. All right, so we're going to move on. We're not going to make you do D here. So let's go on to the next page. This is where it gets fun. All right. Oop, didn't mean to do that. So on this page, this is where we have to figure out the function rule from a sequence of numbers. Now, at the top where it says finding a rule, you're going to see that you can put these in a table. So take a look here. It says a sequence can also be shown in a table. The table gives both the position of each number in the list and the value. So here's your list, 8, 16, 24, 32. Now that list down here is 8, 16, 24, 32. The position is basically where that number is. So the first number is 8, the second number is 16, the third number is 24, the fourth number is 32. So that's the difference. The position is where the number is. The value of the term is the actual sequence from the list. All right, now it says you can write an algebraic expression to describe the sequence. The value of each term can be described as a function of its position. That sounds complicated, but it's not once you see how it works. So we're going to go down to example 3. Now, example 3, I wonder if I can erase, hold on. trying to, I can't, I wanted to erase that red line. All right, so in example 3, it says use words and symbols to describe the value of each term as a function of its position. Then find the value of the 10th term. So there are 3 things you have to do here. And I'm going to highlight those 3 things. First, it says use words. Second, and symbols to describe the value of each term as a function of its position. And then it says, then find the value of the 10th term. So 3 things to do. Now, let's take a look at our sequence here. So remember, this is the position, the first, second, third, fourth number, and the nth number. This is the sequence, 3, 6, 9, 12. Now, we are not going through this way. We're not saying plus 3, plus 3, plus 3. Here, we're saying how is the value related to its position. So from 1 to 3, 2 to 6, 3 to 9, 4 to 12. Now, when I look at this, let me make it a little bigger. I can see that to go from 1 to 3, I would multiply by 3. And 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. And if I continue that, I'll have n times 3. So that's how the term is, the value is related to its position. You take the position number and you multiply it by 3 to get the value of the term. So now here is where you answer those 3 questions. All right, first, remember how it said use words to describe it? Well, look down here. Let me highlight it in black. It says, so the value of the term, I'm sorry, wrong part. All right, look down here. It says, notice that the value of each term is 3 times its position number. That's where you use words. You don't have to use those exact words. You could just say each term is 3 times the position number. Remember, when we're doing that, we're talking about how you go from here to here. You could say, I multiplied the position number by 3 to get the term. Don't just say times 3, but you need a good sentence. Now, remember the part where I said use symbols? Well, I already kind of did that up above, and you'll see here. So I'll highlight this in red, where it says use symbols. Remember how we had n times 3 and I wrote that? Well, that's actually the answer to this. So you would do n times 3. That's using symbols. So I'll write that here. Or n times 3. And last, find the value of the 10th term. So what I'm going to do is I'm going to extend this one more time. And imagine if it goes 1, 2, 3, 4, we have n. Imagine if it was 10. That would be the 10th term. Now, if I just put my times 3 here, I would get 30. So the value of the 10th term is 30. So the 3 things you had to do, write in words. You multiply each position by 3 to get the term. Here's the symbols, 3 times n. Here's the value of the 10th term, 30. All right. Now we're going to go down. We're going to work on E together. Now, same 3 directions. So I'm going to highlight them again. It says use words and symbols to describe the value of each term as a function of its position. Then find the value of the 8th term. All right, so here's what you're going to do. First thing I want you to do is use words. Now, I already have kind of a sentence set up for you. You just have to fill in the blank. The value of the term is blank the position number. So look at the position number. And how do you get the value of the term? From 2 to 12. Look at the position number. How do you go from 3 to 18? 4 to 24. 5 to 30. Now, if you're doing that, it's helpful if you actually write down what's going on. So I know 2 times 6 gets me 12. 3 times 6 gets me 18. And I'm going to write this each time. 4 times 6 is 24. 5 times 6 is 30. And n times 6. All right. So, can you put that into words? Well, all you would say is the value of the term is 6 times the position number. Okay, whatever the position is, you multiply by 6. You could also say I multiply the position number by 6 to get the term. Alright, so that's words. Now symbols, it's already in the table if you did the work I have above. So for symbols, just look right here. Now when you write it using symbols, you just do n times 6. Now don't use the x. You could do n times 6 that way, or you could just write it 6n. So that is using symbols. Isn't symbols a lot shorter than using words? And last, when it says then find the value of the 8th term, what I do for that is I just add another column onto the table, and I put 8 here. And find the value of that 8th term. Remember, the rule, function rule, is times 6. So if I do 8 times 6, I'll get 48. So the value of the 8th term is 48. So the 3 things you had to do: words, symbols, and the value of the 8th term. Now, I'm going to have you do F completely on your own. Remember, words, symbols, find the value of the 8th term. Okay, do it, pause the video, when you're done, start it to see if you were right. Go. Alright, so let's see what you did. Now, I'm looking from the position to the value. So 3 to 7, 4 to 8, 5 to 9, 6 to 10, etc. So I know it's not multiplication because 3 times no whole number is 7. So it's probably going to be addition here. So 3 plus 4 is 7. Does that work for the next one? 4 plus 4 is 8. So it looks like it's going to be plus 4. 3 plus 4 is 7. 4 plus 4 is 8. 5 plus 4 is 9. 6 plus 4 is 10. And n plus 4, I'm writing that down because remember, that's going to be my symbols. So for my words, I would just say you add 4 to the position to get the term. You do not need to have my exact words, but it should say something like that. You could say the value of term is 4 more than the position number. That would be the same thing. Now symbols, remember what I circled right here? N plus 4? Well, that's your symbols. N plus 4. Alright, and last, the value of the 8th term. Remember, it's a good idea to add another column down. And you have the 8th term. Now remember, if the rule is plus 4, 8 plus 4 is 12. So the value of the 8th term is 12. So you had to do words, symbols, value of the 8th term. 3 things. Make sure you have all 3 of those things done. Alright, and now on the next page is the fun of them all. This is a real world example. And this is going to be a function rule that is more complicated than any of the other ones. So we're going to read it here. We'll go over this example, and I'll show you the trick to figure out this function rule, but you're probably going to need extra help from me and extra practice with me to get it. Alright, so let's start here. Okay, it says, the table shows the number of necklaces Ari can make, based on the number of hours she can work. So here's hours, here's necklaces. Write a function rule to find the number of necklaces she can make in X hours. Alright, so normally, here's what I would try. I would try adding, see if I can add the same thing. So, 1 plus 4 is 5. Let's see if plus 4 works. 2 plus 4 is 6. Alright, so adding isn't going to work, so that must mean it must be multiplication, right? Alright, 1 times 5 is 5. 2 times 5 is 10. So this is like, uh-oh. It's not arithmetic. We're not adding the same thing. It's not geometric. So this is kind of going to be tricky here because it's different. So how are you going to get the symbols if you're not plus anything or times anything? So watch how you do this. Whenever you see one of these that isn't adding, isn't multiplying, here's what it means. It's going to be 2 things. It's going to be first you multiply or possibly divide. Usually first you multiply, and then you're going to add or subtract something. So you're going to multiply, then add or subtract something. So this is how you get it. First, look at the number of necklaces here, going from 5 to 7 to 9. You see how this sequence is plus 2, plus 2, plus 2. Now that tells you the first part of the rule. Since you're going up by 2, you're going to start with 2x. Now, it's going to be 2x plus something or 2x minus something. So watch what I'm going to do. I'm going to multiply each of the x values by 2 and write those down right here. So, if I do 1 times 2, I get 2. 2 times 2 is 4. 3 times 2 is 6. Alright. Now, how do I go from those red numbers to the number of necklaces? This is where I should see a pattern. So, if I go from 2 to 5, I know I add 3. 4 to 7, I add 3. And 6 to 9, I add 3. So that gives me the second part of the rule. It's 2 times x plus 3. Now remember where I got both of them. This is the tricky part. The 2 times x I got because the sequence skip counted by 2. That's the 2x. Now the plus 3 came from after I multiplied each number by 2, you had to add 3 to get the rest of the way. So, when it says up here in the directions, it says, write a function rule to find the number of necklaces. My function rule is 2x plus 3. That's all I had to do for this one, but that is a complicated rule. So if you have to rewatch this again, that's possible. Plus, I'm going to be helping you more with those. So, your job is done with me. Now you just need to finish the rest of the work on your absence sheet or whatever you're supposed to do and ask me any questions. Thank you very much.